Have you ever wondered what the universe is really made of? This vast expanse of space and time, filled with galaxies, stars, and planets, is still largely a mystery. Theoretical physics plays a pivotal role in our quest to understand the universe's intricate fabric. It's a fascinating journey with one key player at the forefront: string theory. This idea, as strange and complex as the universe itself, could hold the answers to our cosmic questions. And to answer this question, we delve into the realm of string theory. Imagine if the smallest particles in the universe were not particles at all, but tiny vibrating strings. That's the basic premise of string theory, an idea that challenges our understanding of the universe down to its most minuscule constituents. In the realm of string theory, particles as we know them take a back seat. Instead, the universe is composed of one-dimensional strings. Yes, you heard that right, one-dimensional. These strings are so infinitesimally small that they evade our conventional perception of dimensions. Now, these strings aren't just sitting idle. They're vibrating, each oscillation creating a unique pattern that, much like a fingerprint, differentiates one string from another. This is where it gets fascinating. Each unique vibration corresponds to a different particle. That means every particle we know about, from quarks to leptons, from photons to gravitons, could be the manifestation of a string's specific vibration. The diversity of particles in the universe then is a result of the myriad ways these strings can vibrate. But hang on, there's more. Strings come in two varieties: open and closed. Open strings have two separate endpoints, while closed strings loop back onto themselves, forming a continuous circle. It's proposed that closed strings give rise to particles such as gravitons, the carriers of gravity, while open strings correspond to other force-carrying particles. You might be wondering, why does all this matter? Well, if true, string theory provides a unified framework for understanding all the fundamental forces of nature. It's a theory that beautifully marries the macrocosm of gravity with the microcosm of quantum mechanics, a feat that has eluded physicists for decades. But remember, string theory, while captivating, is still a theory. It's a tapestry woven from mathematical elegance and theoretical boldness, awaiting empirical validation. So in essence, the universe dances to the tune of these tiny strings. Each vibration is a note in the grand symphony of existence, each string a player in the cosmic orchestra. This is the universe according to string theory, a harmonious, interconnected dance of tiny, vibrating strings. But where do these strings vibrate? In dimensions beyond our comprehension. Let's take a step back and think about dimensions. We live in a world with three dimensions of space: up and down, left and right, and front and back, and one dimension of time. But string theory proposes that there are actually more dimensions than we can perceive. Yes, you heard it right, more dimensions. In string theory, these strings of energy don't just vibrate in the three dimensions we're used to, but in multiple dimensions. Some theories even propose up to 10 or even 26 dimensions. These are dimensions beyond our everyday experience, dimensions that are folded up so tightly that they're almost impossible to detect. But the question is, where do these dimensions exist? This is where D-Branes come into play. D-Branes, or Dirichlet branes, are objects within string theory that strings can attach themselves to. Think of them as multidimensional membranes on which strings vibrate. These D-Branes could exist in any number of dimensions, providing the framework for strings to vibrate in more than just our familiar three dimensions. This concept is a radical shift from our conventional understanding of the universe. It challenges us to think beyond what we can see and perceive. It's an idea that takes us out of our comfort zone, stretching our understanding of the universe beyond the familiar three dimensions. So our understanding of the universe becomes not just 3D, but multidimensional. So what does this all mean for our understanding of the universe? It means we're rethinking the very basics. String theory suggests that at the heart of every particle, there's a tiny, one-dimensional string. These strings, like musicians in an orchestra, vibrate at different frequencies. Each vibration, each note, gives rise to a unique particle. Imagine a symphony, but instead of instruments, we have dimensions. Not just the three we know: length, width, and height, but potentially up to 7 additional ones. These dimensions, like sheets of music, cradle the vibrating strings, guiding their harmonies. And then there are D-Branes. These are like the stages upon which the strings perform, spaces where strings can attach and move, shaping the universe as we know it. In the grand symphony of the universe, every note is the vibration of a string, every melody is the dance of dimensions. And while we may not yet fully understand the music, we continue to listen, to learn, and to explore.